mine. What do you feel?
Alright guys, today we're going to be having our first lesson on matrices, and before we actually begin discussing, there's just one thing I want to get out of the way immediately. Now, you should know by now that you have different types of brackets. First of all, you have curly brackets, you have parentheses, and you have square brackets. Now, right off the bat, this one here, the curly brackets, is never used for matrices. So nobody should use this one when you're doing any matrix problem or any problem on matrices. Now the parentheses, this is the one that I'll be using, and you'll see this used in some textbooks as well, and you'll also see this used in some textbooks. So as far as in terms of my doing the lessons with you, I'll be using parentheses. All right, so let's get that out of the way. So you never use curly brackets for matrices. Curly brackets are reserved for this topic, which you should have been familiar with, sets. So we're not dealing with sets. So we don't use curly brackets. We can use parentheses, square brackets, but this is the one I'm going to be using predominantly in this lesson. All right? Okay. Now, back to what we're talking about. Now, one of the questions I asked at the end of the last class was, what is a matrix? And a matrix is simply a rectangular array of elements. Now I'm going to give an example of a matrix. So here is one. I'm going to put 2, A, 3, 5, negative a half, and x plus 1. Okay, so here's an example of a matrix. And we said that a matrix is a rectangular array. Now, array means how things are arranged. So when we say a rectangular array, we really mean how things are laid out. So if you look closely here, you'd kind of see a rectangle, right? So that's what we mean by rectangular array of elements. So a matrix is simply a rectangular array of elements. Now, what do we mean by elements? An element can either be a number, for example, is 2, negative a half, 3, etc. It can be a letter, like in this case, A, or it can be an algebraic expression, for example, in this case, x plus 1. So a matrix, simply, let me do another example here. A matrix can simply contain numbers alone. For example, here. Okay. So here's a matrix that is comprising of elements that are just numbers. So those are examples of matrices. And also, a matrix can comprise of algebraic expressions, like this one. Okay, all right. Or we can have matrices looking like this. Or we can have matrices looking like this, for example. Now, let's go back to the first sheet. Now, notice here that there's ample space between these elements. Ample space. So when you see me do a matrix and ample space is being given, then it means that you should follow suit. Now, what do I mean? Here's what I mean. This matrix here that matrix there is very different from this matrix. Okay? So when you see me emphasize distance between elements, that's what you should do as well. Okay? So let's go back again. So a matrix is a rectangular array of elements. Again, why rectangular array? Because if you just do this, which you're not going to do, I'm just emphasizing the rectangular issue. you'll actually see a rectangle. And even when it's like this, it's classified this as a rectangle as well. All right. So you look at it and you see rectangular array. So a matrix is a rectangular array of elements, and these elements can be numbers, letters, algebraic expressions, etc. So this is an example of a matrix. Here's another example of a matrix. This is an example of a matrix. This is an example of a matrix. This is an example of a matrix, etc., etc., etc. So we know that a matrix is a rectangular array of elements, and those elements can be numbers, letters, or algebraic expressions. Okay? Now, the next thing that we need to know and master is what is referred to as the order of a matrix. The order of a matrix. So I'm just going to make a note of that because I want that terminology to stand out. So I'm going to write here the order of a matrix. Very, very important for us to understand, because if you don't understand the order of a matrix, then you're going to run into some problem when you start looking at questions and when you start learning about conditions on how to use matrices and actually doing working on problems. So the order of a matrix is extremely important. Now, what do we mean here? Now let's take a look at these two. Now, an order of a matrix refers to the number of rows and number of columns a matrix has. The order of a matrix refers to the number of rows and number of columns a matrix has. Now, the number of rows always comes first. What do I mean? Here we have a matrix, and this would be classified as row 1, which means the elements that are in row 1 are 7 and 3. So this is classified as row 1. This here would be classified as row 2. So the elements in row 2 would be 1 and 4. Now let's talk about columns. Now this would be the first column. So the elements in the first column would be 7 and 1. And the elements in the second column, C for column of course, would be 3 and 4. So this matrix here, this matrix has 2 rows and 2 columns. So the order of this matrix is normally indicated, subscripted here, because this matrix has 2 rows. Remember, we always ask ourselves how many rows a matrix has first. So this matrix clearly has 2 rows. So we just simply indicate that here, and it has 2 columns. So we say that this matrix is a 2 by 2 matrix. Right? This doesn't mean multiply, it means by. For example, if you go to the hardware store and you buy a piece of lumber that is 3 by 2 or 3 by 5, etc. So this is just stating that this matrix here has, first of all, 2 rows and 2 columns. So it is a 2 by 2 matrix. Now let's take a look at this matrix here. Now if you look closely, the elements are 73 and 14, which is completely different from what you're seeing here. These elements are 7, 3, 1, and 4. So the element that would be in row 1, column 2 would obviously be 3. The element that is in row 2, column 1 would be 1, and so on. So this matrix here would be completely different from the one that we just examined. Now, when you look at this matrix, that's 1 row, that's a second row. So we know that this matrix has 2 rows. So we indicate the 2 there. But remember, this number is 73. So that's one number here, and that number is 14. So this matrix actually has only 1 column. So this matrix would therefore be a 2 by 1 matrix, which means it has 2 rows and 1 column. And that's what we mean by the order of a matrix. Now let's look at other sheets that we did examples of matrices with and see if we can figure out the order of those matrices. Now let's take a look at this one. Now, how many rows are you seeing in this matrix? Let's focus on this matrix here. How many rows are you seeing? Clearly, we have one row here and we have another row here. So this matrix has 2 rows. So we indicate it subscripted like that. Now when you look here, there is 1 column, there is 2 column, and there's the 3rd column right there. So this matrix has 3 columns. So the order of this matrix would simply be 2 by 3. Very, very simple and straightforward. What about this one? Here we have 1 row there, 2 rows. We have 1 column there, 2 columns. So the order of this matrix would be 2 by 2. It's as simple as that. But it must remember that the number of rows always comes first. So that's row. That always comes first and then column. Very, very important. Now let's take a look at this one here. Very straightforward as well. 1 row, 2 rows. So we have 2 rows. That's 1 column, 2 columns. So it's a 2 by 2 matrix. So the order of that matrix is a 2 by 2 matrix. Now, it's very important now. These two will emphasize the importance of stating the number of rows first. Now, when you look at this matrix here, we have 1 row there, 2 rows there, and we have 1 column. So the order of this matrix is 2 by 1. But when you look at this matrix down here, you're clearly seeing that it's just 1 row. However, this is 10, there's a big space there, and this is 1. So this is column 1, and that's column 2. So the order of this matrix, it has 1 row, so 1 comes there, and 2 columns. So it's a 1 by 2 matrix. So the order of that matrix is 1 by 2, which means 1 row and 2 columns. So note the difference between a 2 by 1 matrix, which looks like this, and a 1 by 2 matrix that looks like this. All right? So, very, very straightforward, very, very simple. So what I'm going to ask you guys to do now is to give examples easily of the following. So you're going to give examples of a 1 by 3 matrix, a 3 by 1 matrix. You're going to give me an example of a 2 by 3 matrix. Give me an example of a 3 by 2 matrix. So I want examples of each of these now. So please replay the video as many times as you want, and then give me some feedback as quickly as you can. All right, I hope you found this video insightful. See you guys on the next video.